Okay, almost done. Those should be the last 15 minutes of the video about the homework. So we stopped at this slide, at this problem before the last recording, at the last recording. So let's go to the slide number, so to the homework, I think, number 12, at least for me is number 12. And let's see what happens. So they are saying which of the following ions will act as a weak base in water. Well, if you look at those, every single one of those are weak bases, right? Because this is the weak acid, HF, right? Has lost the H, so it's just a weak base because when it takes the hydrogen, takes it and becomes a weak acid anyway. So all of those actually work. Then for number 13 instead, determine the pH. So what I did in this one, in this problem, so you have KF. So let's go back again. Determine the pOH. Okay, so pOH, watch out, it's not pH, of a solution that is made of that much moles per liters of KF, and you have the Ka for the hydrofluoric acid. Now, if you have the acid though, so keep in mind that probably this is not what you need because you're dealing with KF, of which you have concentration. But when you break it in water, K floats away, so it doesn't form any KOH. Remember, because KOH doesn't want to stay because it's a strong base, dissolves very fast and completely. So the only thing that you have left is F minus. Once you have F minus, basically you can use this equation to determine how much concentration of F minus you're going to have. Once you know it, then you can start your reaction in water. So you have a minus plus the HOH. So you know that F minus is willing to take aboard some H because even if it forms the acid, it doesn't dissolve completely, but it's a weak release. So there's always going to be some HF formed. So if X is the amount, then OX is also the amount of OH floating around freed from the H, because the H are busy with the F forming the acid. So there are some OHs that are just increasing the pOH in water. So at that point, you just calculate your Kb because that's what you need to do the calculation. This is the amount of OHs, therefore you calculate your pOH because that's the one that problem is asking. Next problem is, so this one we did. Number 14, the problem is dealing with which of the following aqueous solution has the highest OH minus. Now, be careful because highest amount of concentration also deals with, so in this case, what you have, if you're looking for a highest amount of concentration, this also means that you have a small, so highest amount means that you have a very basic solution. Now, if you have, for example, a 10 to the negative 4 molar solution of HNO3, and you know that this is acid, right? This one has a pH about 4. This one has a pH about 3, right? Because both of those are acid. So those are about the pHs that you're going to receive. This one tells you directly this is pH of 3. So pure water instead of pH of 7. Right? And if you have a pOH of 12, doesn't mean pH of 12. The pOH of 12 means a pH of 2. So the pure water is the only one that has a pH of 7, right? Which means that the negative 7, which is for the pH, which means it has the highest amount of OHs instead, which is opposite to the pH. Next problem tells you calculate the pH of this anilinium hydrochloride. Now, probably you don't know what anilinium hydrochloride is, but this is what I want you to think about. So they give you the formula, so you have something like that, and then you have the Cl. Either you know that this is a cyclic hydrocarbon structure with the NH3 hanging there, and then you have the Cl minus, but even if you don't know, you know that this compound breaks between the C6 H5 and NH3 then break and Cl is floating around alone, because you know that HCl is a strong acid, so Cl is willing to be removed really fast because it's a halide element. So if this is going and this is negative, obviously this whole compound here is going to be positive. So now you have your compound which is positive. You make it react with water, which means it's releasing the proton. If this is positive, right, or wants to lose the positive charge, which means loses one of those H's. So it's behaving like a base. I'm sorry, it's behaving like an acid because it's releasing the proton. They give you the Kb, so first thing you got to do is to calculate your Ka, right? And I did it right there. So Kw over Kb, so this is your Ka. Once you have the Ka, according to the table, this is how you solve, and this is your pH for that particular problem. Number 16. You have, so which one of the following has the lowest amount of OHs? Lowest amount of OHs means the highest pOH, right? Because means the highest amount of pOH means the lowest pH, which means a lot of H pluses and a little OH minuses, so that's the one because it's the only one of pOH of 12. This one calculate the pOH. So again, you have a problem there, and you have the anilinium again, hydrochloride, which we said before is going to break down right there. So you have the Cl moving around, and you have this part of your compound which is positive. They are giving you the Kb, so probably it's not a good choice. So you got to calculate your Ka first, solve like before, and calculate your pOH, and then because they are saying calculate pOH, so you stop right there, but you will calculate the pH first. After that, you have Ka for this, so what is pH in this solution? So again, one more problem about that. So this is your HCN, for which they are giving you Ka, but they are saying you're dealing with sodium cyanide. So if this is sodium cyanide, breaks in water like that, so this is the transposition of those molar solutions of the amount, the concentration of the cyanide at that point. Na plus, nobody cares. Nobody cares because this is just floating in water, is now forming sodium hydroxide. So now you take the Cn minus because that's the amount you have been given and make it happen. So this one has a minus, so behaves like a base. So Kb is actually what you need. But they are giving you Ka, so that's not good. You need to go to Kb first to solve for H. For X, once you have X, this means you have the amount of OH minus in place, so for pOH and therefore for H. And this is the number. For 19, you have, well, in this case, you don't even need to think too much about something because you have a solution, but you have a pH of 2, so this means it's a strong acid, right? Because you have a lot of pH there, right? A lot means in the negative side there, in the lower extent, in the lower end. In this case, you have Kb for the NH3. They want to know pH if you have something like this. Now, something like this, remember, is going to break down. Cl is a minus, right, because it's a halide. So it's a -1, so this one moves away. So NH4 becomes as a NH4 plus. So probably you're not needing the Kb, you need the Ka instead. So, and that's basically what I've done. So NH4 and Cl, you break it down. This one keeps on floating. So now you know how to transport the molarity 0.45 from this solution to this solution. So it behaves like an acid. So this is your table. And you need to find the Ka because you have been given the Kb. And again, solve and find the pH for that number. Next is going to be number 21. And at this point, I think you're done with those problems. Right, that was the last one. So this is really fast at this point. So which acid has the larger acid dissociation constant? So larger acid dissociation, which means which one is the one that will be releasing the most, right? It will dissociate the most. Well, the one with the most number of ions because you have more bonds to deal with, so you're willing to let go one. Remember how we explained that one? And then you have what group is the hydroxylic one? Well, that's the one COOH. Am I missing anything from the past? No. Okay, 22, we just said it. 23. 23, according to these properties there, do you think that HI is what according to this? Well, yes, it follows the trend, so becomes stronger as an acid, so that's a good one. And then number 24. Number 24, you have a series of things to decide from, and they say based on their composition and structures and on conjugate acid-base relationship, select the stronger base in each of the following. So between Br and ClO, Br O minus is the one that has the majority of those electrons, I should say. Therefore, will act as a stronger base. Also, so both of them, when they are combined with the H, both of them are weak acid. And the weaker, so they want to know that was stronger. So the weaker acid is the one that has the BrO minus. And so the stronger base, the weaker acid is this one because it's the one that has not many oxygens or ions, electrons to get rid of. So this is the one that becomes the most polarizable. So this one also becomes the stronger base. Between those two, well, the choice is easy because this is the one that is a stronger acid because it has more O's. So the one with least amount of O's instead is the base. This one you have more 2 minuses, so this is also willing to be a stronger base. And what else you have? This one said the stronger base out of those, so this is the choice because you have less O's, right? Because again, the more the O's, the stronger the acid. So for the base follows the opposite. This one again has a higher number of 2 minuses, so it's a stronger base, whereas if you have a higher charge, positive charge, is a stronger acid, remember? And the last one, in general, the acidity of a binary acid increases from left to right. Yeah, that's true. In a series of acids that have the same central atom, acid strength increases with the number of hydrogens. No, increases with the number of oxygens eventually. And hydrotelluric acid, so you have the H2TE and H2S. They say the difference in strength is due to the electronegativity. No. So, and you're done with this assignment. Again, please let me know if you need any further assistance.